Rise and grind, folks. Guys, I am on the way to an existing maintenance customer. This is an AC maintenance. I believe this customer has a heat pump that we put in a couple years ago. Knock on wood, nothing has been replaced ever since. I'm almost there right now. Let's go take a look. I'll see y'all when I get there. Guys, inside, this customer has a downflow air handler. It was a 20 by 20 by 1 filter. I replaced that and I just flushed the P-trap. And as of right now, I think today is a high of 70, I believe. But right now it's about 51, 52 degrees. I got a 20-degree split inside. Make sure I turn my thermometer off. Yep. Now let's move some stuff out the way. And let's get to opening this door. I'll be right back. This is a 2.5 ton, less than 2-year-old R14A heat pump. I believe the older system, actually no, I'm thinking of another heat pump we put in. This one had a Freon leak, the evap coil inside, and I think this customer had a few leaks at the condenser coil. We did a leak check out here, and due to the age, I think that was the original heat pump that was here. That heat pump had to be at least 20 years old. Due to the age of that heat pump, the customer decided to just rip everything out and start off on a clean slate with a new heat pump system. But guys, let's get our amp draw reading. And right now I'm probably going to kill the power after I get the amp draw, and we're going to test the cap. I'll be right back. Guys, outdoor fan motor, 0.60. And the compressor, 4.7. Alright. With that being said, let's kill the power and let me check that cap. I'll be right back. Guys, if you know, you know. While my wires are out on that contactor coil. But now, what is this, a 35.5? Now you guys heard me mention this in previous videos. Usually with straight AC condensers under 2 years old, at that point, there's not enough wear and tear for the numbers to go down. Meaning we typically won't check capacitors under 2 years old on straight AC units. However, with heat pump units, since these heat pump units run year round, 2 years plus, at that point, it'll be worth at least testing the numbers. And guys, once again, the point of the maintenance is to avoid breakdowns, but we're hoping there's no wear and tear. But that's the point of the maintenance, is to catch parts before the ratings go down too low. And on the first 90-degree week next month, you don't want a potential part out of range to cause more issues with the compressor or the fan. And I may have to scratch the terminals up here to get a reading on my compressor side, but let me see real quick here. Yeah, I need more surface contact here. Let me zoom out. Looks kind of crazy here. All right. Here we go. 34.9 is good. .9 is good. All right. 34.9 out of 35 and 4.9 out of 5. That is good money. And there isn't much of any debris. Remember, we come out here twice a year, so I know we came out here a few months ago for the heat pump heat maintenance. Everything's still clean as long as you can see the bottom of the of the heat pump. There is no reason to pop the top to remove any twigs because you can still see the bottom here. I think last year we actually popped the top to remove a small amount of debris, but all right guys, with that being said, let me put this back together and I'm going to check for a potential difference on that contactor. I'll be right. This carrier heat pump had a discharge temp switch. Now, real quick, guys, I mentioned this a bunch of times in different heat pump videos. This right here is my discharge line for my compressor. Usually a DTS will mount on the actual discharge line, hence why it's called a discharge temp switch. If the discharge temp exceeds a certain temp, it's going to open up the contactor coil and it's going to cause the AC to turn off until the technician rectifies the problem. Now, this here is my Defrost thermostat switch. Not to confuse the two. Your Defrost thermostat is nothing more than just a sensor that senses the outdoor coil temp. This doesn't really matter in the summer, but in the winter, once the coil temperature gets below a certain point, this Defrost thermostat is going to send a signal to your board that says, wait a minute, my coil is too cold, let's initiate our defrost. So at that point, once it initiates defrost, inside your emergency heat is going to turn on, and then for 2, your 4-way valve or your reversing valve is going to switch temporarily to AC, and it's going to send hot gas straight from your compressor through to your condenser coil, which is going to melt the ice. Now, how long this is going to take, it could be 60 seconds, could be 90 seconds, depending on the manufacturer specs. But once the coil temperature outside gets above freezing, that's when the defrost thermostat is going to close, and this heat pump is going to switch back to heating mode. But when in doubt, guys, always refer to the schematic. This will let you know if you got a defrost thermostat or a discharge temp switch. They both could look the same, but once you see the location, you can't really confuse one for the other. But all right, let me put this back together. I'll be right back. All right, I got this freaking bee here now, guys. I think this might be a wood bee. I don't think this is like a bumblebee. All right, take 2. If that bee comes back, I'm packing my shit up and leaving. All right, guys, no potential difference across my contactor, and the customer do have a perforated fence. Not touching the heat pump, just around the heat pump. That is okay. I just make sure the customer knows to keep anything from within direct contact of the coil. But the coil itself is clean. I think they got a hose spigot on the other side of the garage, but the coil is clean. Guys, let me put the door back on. I'll be right back, guys. That's all there is to it. Brand new 13 SEER carrier 2-ton heat pump. Everything's still rocking and rolling. I got to do the paperwork, and I got another call that just came in. Keep rocking and rolling, guys. I'll see you in the next one. Peace.